Hello, this is Deepak. Welcome back to Cisco Networking with Rajput. Today we are going to talk about BGP rule of synchronization. BGP rule of synchronization was turned off in iOS release 12.2 within bracket 80 and later. Prior to this, the rule was switched on. So what exactly the rule is? An AS which provides transit services, it will not advertise the route learned from IBGP peer to EBGP peer until the route is learned via an IGP. Let us try to simulate the situation. This is the scenario where we have four devices, router 4, router 1, router 2 and router 3. Router 4 will have EBGP peering with router 1 and the subnet which is used is 14.1.1.0/24 and R1 and R2 will use 12.1.1.0/24 and in the same way router 2 and 3 will use 23 subnet. And on the loopback interfaces, router 4 has 44.44.44.44/32 subnet. R1 and R2 have 1/32 and R2 2.2.2.2/32 and R3 has loopback 1 interface configured, that is with subnet 33.33.33.33/32. So over here R1 and R2 are providing transit services. Both of these will be having a BGP ASN 100 and R4 will be having BGP AS 400 and R3 will have BGP AS 300. So the key to this lab is the rule of synchronization. So what we will do, we will switch off the rule of synchronization on router 4 and router 3, but we will let it on router 1 and router 2 so that we can see or we can simulate the situation, what exactly the rule of synchronization says and how it will prevent the devices from advertising prefixes if they are not backed by IGP. So what we have done for IBGP peering, we on router 1 and router 2, we would require to enable some IGP so that we can have reachability on loopback 1 interfaces of router 1 and same on the loopback 1 interface of router 2. So let us go to live devices. Okay, let us first go to router 1 and router 2 so that we can enable IGP and we can have IP reachability for IBGP. So first of all, show IP interface brief and see if we can reach the other end. Okay, we can reach router 2. Let us go to configuration mode and uh, we are going to use OSPF as IGP. Network and the loopback 1 interface. Okay, let us go to router 2. Okay, the interfaces and router OSPF 10. The network 12.1.1.2 0.0.0 area 0 and the another network. Okay, let us give some time to OSPF so that it can have its neighborship or adjacency up to show IP root OSPF. And we got one prefix in OSPF that is being advertised from router 1 and that's R1's loopback 1 interface. Okay, let us start working on IBGP configuration. I'm first going to R1 and let me configure R1 for IBGP, router BGP 100, neighbor 2.2.2, remote is 100, neighbor 2.2.2, update source loopback 1, and next hop self. Okay, router BGP 100. Now we have switched to router 2 to configure BGP over there, and let us configure IBGP neighbor 1.1.1, remote is 100, update source loopback 1, next hop is self. Now we have configured IBGP between router 1 and router 2. Now the another component which we need to work on is EBGP configuration on router 4 and router 1, and another EBGP session we need to configure between router 2 and router 3. So let us first go to router 4 and see what is configured over here. Physical interface is configured, loopback 1 interface is configured, show IP protocol nothing. So let us go and configure router BGP 400 and neighbor remote is 100, and we are going to advertise this prefix which is configured on loopback 1 in BGP 44 44 44, and the mask will be /32, so it will be written as 255 255 255 255. Let us go to R1 now, and we need to configure EBGP between R4 and R1. For that, what we need to do, we need to define neighbor 4, the neighbor 14.1.1.4, remote is will be 400. Okay, hopefully we should see BGP message. It's up now. Let us go to router 2 and router 3. We need to configure EBGP over here. So first on router 2, we need to configure neighbor 23.1.1.3 and remote AS will be 300. Let's go to router 3. Again over here physical interface is configured, loopback 1 interface is configured, and show IP protocol nothing is configured. So let's go. Let us go to R3, configure router BGP 300, neighbor will be 23.1.1.2, and the remote AS is 100, and the network which we want to advertise is 33.33.33.33. Mask will be 255. It's a /32 subnet mask. Okay, let us start viewing from R4 to show IPBGP summary. Okay, we have neighborship up. So 44.44.44 is BGP router identifier, and its local AS number configured on the router is 400, and BGP table version is 3, which should be again marked over here. Main routing table version again 3, and this is how much memory it has consumed. So basically this is the neighbor which we have configured, and BGP version which both the neighbors agreed to use, and this is the AS number which is configured on remote end. This is messages received, messages sent, table version, and how long the session is up, and state prefix received is number of prefixes we are getting, this router is getting from its peer. So currently R4 is getting only one prefix from R1. Well, let us first go to router 1 and see if we enable synchronization or no. Do show run section router BGP. Synchronization is off. Let us enable synchronization on both the routers R1 and R2 because these are the key routers for us. Both of these routers are playing the role of transit AS. Let me clear BGP sessions. Let us check. We got BGP. Do show IP BGP. There are two prefixes. One, it is getting from R4. Another one, it is getting from IBGP peer. And see, this is not the best route. Now let us go to router 2. Show IP BGP summary. Again, two entries, one for each peer. Let us check the BGP table. Same picture over here. Router 2 is getting two prefixes, one from EBGP peer, that's R3, and another one it is getting from R1, that is IBGP peering. And again, this is not the best route. Okay, let us be little more specific about the prefix we were interested in, and this prefix is not advertised to any peer because it was not synchronized. The prefix entry which we see in BGP is not there in IGP. So IGP is not backing this prefix, that's why this is not advertised to EBGP peer. Let us check on router 1 as well. It will be for 33 subnet. Again the same picture, not advertised to any peer, and the reason is it is not synchronized. So the rule of synchronization says an AS which provides transit services, it will not advertise the route learned from IBGP peer to EBGP peer until the route is learned via an IGP. It's time for a question. Can we use physical interface IP addresses as peers to have IBGP peering, specifically where multiple hops are there in between BGP peers? You can use above design diagram for your reference. So I just want to specifically mention that R2 is not running BGP. Please leave your comments in below comment section. Thank you for watching. Hope to see you again.